This is section 10.8, quadratic formulas, and using the discriminant, part of the quadratic formula, to determine how many solutions we have. I've drawn three different parabolas on our graphs below. Our first parabola, you can see, does not touch the x-axis in any location. So, it has 0 x-intercepts, or it has 0 solutions. Our second problem comes down and touches the x-axis once and then goes back up. Therefore, it only has one solution to the problem. And that solution is at that blue dot. Our third problem, it's obvious the parabola comes down and goes through 2 times, so it has 2 solutions to the problem. Now, as a sidebar, we need to understand we have a lot of different ways we can refer to a solution of a problem. We're going to talk about those words in just a little bit. But as we think of the quadratic formula, which as a reminder, we want to take a look at what that quadratic formula is. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, today we are going to focus on something called the discriminant. And the discriminant is the part of the quadratic formula that is underneath the radical sign, which is what I've circled right here. This part that's underneath the radical sign is very critical to look at, because if this number is less than 0, in other words a negative, we know that we can't take the square root of a negative number. That is a circumstance where we have shown in this first parabola. And so, 0 solutions is going to occur when b squared minus 4ac is a negative number. You may want to write these notes and copy these diagrams over on the left, on the blank paper to the left of the notes. When the b squared minus 4ac is equal to 0, that's an example of what we have going on in the middle, where we just have one solution. And so that's only going to happen on a very rare occasion that it's actually equal to 0. And then our most common and normal solution is when b squared minus 4ac is a positive number. And if it is a positive number, we're going to have 2 solutions to the problem. So, just as a summary, when it's a negative, it doesn't cross at all. When it's 0, it crosses once, and when it's positive, it crosses twice. So let's fill this material in and these ideas in on our next page. First of all, what is the discriminant? The discriminant is b squared minus 4ac. When it's a positive number, we have 2 solutions. When it's 0, we have 1 solution. And when it's a negative, we have 0 solutions. Now, I mentioned before that there's a number of different words that can be used to refer to a solution to a quadratic equation. Those words, as you know, are solution, answer, but there's some other words as well. It's where it crosses the x-axis. That's called an x-intercept. Or, as we're going to learn later in the year, it could also be referred to as a root. In other words, what are the roots of the equation? So if you were asked any one of these 4 different interpretations, you need to understand that they all mean the same thing. Give me the values of x. So let's look at our examples. Our first example is very simply x squared minus 3x plus 4. We have to identify the values of a, b, and c on each of our problems. Well, that's 1, -3, and 4. Now we're going to evaluate for b squared minus 4ac. When I plug in my values of -3 minus 4 times a times c, and I work this out, I'm going to very simply say, what is -3 squared? 9 minus 16. Well, that is a negative number. All we need to determine is if it's a negative number or a positive number. And now we can say if it's a negative number, there's 0 solutions. Our second problem, it's not equal to 0, so we have to start the problem by adding 12 to both sides. This gives us a value of a equals 1, b equals negative 8, and c equals positive 12. As we evaluate into our discriminant on this problem, our b squared negative 8 squared minus 4 times a times c is going to be 64 minus 48. This is a positive number. Since it's a positive number, as we look at our key from above, we see that we have 2 solutions. Part C and Part D very simply explored 2 other possible scenarios that we could have for the discriminant. As we examine Part C, we realized that we don't have a constant. We don't have a c, and so c equals 0. We do have a as 1 and b as negative 6. So, what is the impact on our discriminant? Well, b squared minus 4ac is still going to be in play. We have negative 6 squared minus 4 times 1 times 0. That's 36 minus 0, which in this case is positive. Since it's a positive answer, we have 2 solutions. Our fourth and last one in this set, we have an x squared term of 1. We don't have an x term, so that's 0, but we do have a c term of negative 12. So we plug this into our discriminant, b squared minus 4ac, and we have 0 squared minus 4 times 1 times negative 12. Well, that's 0 plus 48. Once again, that is a positive. So, as a solution, we're going to have 2 solutions to the problem. In example 2, the question asks to find the number of x-intercepts. The number of x-intercepts, if you remember, is really the same question as the number of solutions. So, let's try these 2 problems. A equals 3, b equals negative 4, and c equals 6. b squared minus 4ac is still the method we're going to use to determine if it's positive, negative, or 0. Negative 4 squared minus 4 times 3 times 6 is 16 minus 4 times 3 times 6 is 72. That's a negative number. And since it's a negative number, we refer to our top chart and we see that that means there's going to be 0 solutions to this problem. Let's look at our last one. A equals 1, b equals 9, c equals negative 75. Our discriminant here is b squared minus 4ac, so that's 9 squared minus 4 times 1 times 75. That's 81 minus 300. Once again, that's a negative number. So there's 0 solutions. As we analyze our 6 problems, we see that all 6 of our problems have either 2 or 0 solutions. And so that leads us to a question. When are we going to have only one solution? Is that going to happen very often? Well, honestly, it's not. Because as we remind ourselves, when we have positives or negatives is we're going to have 2 or no solutions. On a very rare occasion, will the b squared minus 4ac actually equal 0?